Welcome to HoloBio, the open source interface for digital graphic microscopy. Here on the main menu, we have two big panels, one for the real-time acquisition and the other for post-processing image. Both panels have the option for DHM and DLHM. In this video, we're going to pick real-time for live acquisition DHM. In this opportunity, we are going to do these examples with a Mac sender setup in off-axis configuration. This is the DHM real-time package for real-time processing. On the main screen, you will see two areas. On the right, the visualization windows. On the left, the parameters control. Before starting, make sure your DHM setup is connected and the camera drivers are properly installed. From the toolbar, click Load. You can either load a video or connect to the camera. For this part of the tutorial, we will connect it to the camera. Now let's set the system parameters. In this case, the wavelength is 633 nanometers and the pixel size is 3.75 micrometers. Next, in the Fourier transform module, choose the filter geometry, circular or rectangular. With everything is ready, click Compensate for starting the reconstruction. Now, in the first viewer, you can switch the view between the hologram and its Fourier transform. You can also choose to see the Fourier transform with or without the special filter. If you want, you can turn the log scale on or off for the Fourier view. In any view, you can zoom by dragging over the area you want to see. To go back to the full image, right-click. For the amplitude reconstruction image, you can switch between amplitude and intensity display. To save a single frame, click Save in the toolbar. Choose what you want to save, set the file name, and pick the folder. If you prefer to save a video of the reconstruction, use the record option panel. Select what you want to record, press Start to begin, and stop when you are done. For the second part of this tutorial, we're going to explore how the particle tracking section of the interface works. First, we start to load a video. This will be the sample where we want to track the particles or the objects of interest. Next, we select the type of filter to apply. There are two options able, Gaussian filter and bilateral filter. The option depends of your sample. For example, if your sample has a lot of noise or texture, the bilateral filter may preserve it better. Then you can decide whether to use the color filter by acting or disacting the corresponding button. If you enable it, you will need to set the blue color value to either 0 or 255. Use 0 when the background is bright. Use 255 when the background is dark. After that, specify the minimum and maximum area in pixels of the particles or the samples you want to track. This helps the algorithm ignore objects that are too small or too large to be relevant. Next, configure the P, Q, and R parameters of the Kalman filter. These parameters control how the algorithm predicts and corrects the position of the particle in each frame, improving the continuum of the trajectory. Finally, decide how you want the result to be displayed in pixels or in work coordinates, for example, micrometers. If you choose work coordinates, activate the corresponding button and enter the magnification value of your optical system. Once everything is configured, press the tracking button and the software will automatically detect and follow each particle across the video frames. Finally, when tracking ends, the graph of the object's trajectory appears where the dots indicate where the sample begins and the X indicate where it ends. In addition, we obtain a table with the X and Y position for each of the particles in each frame and the elapsed time.